First step that we do once the engine arrives here at the so-called turbo hall is unwrap it and put it on pedestals. This is the moment where we can start the incoming inspection. The incoming inspection consists out of an inventory check, a visual check for transportation damage and suspected unapproved parts, a completeness check, a borescope inspection, and a filter check. The inventory check is done by Vocollect system. This is a system where the inspector wears a headset and reads out every part and serial number of the components attached to the engine. That information is fed into our SAP system and can be used for further work scoping and part processing. Next, what we do is we take a lot of pictures of the engine. First of all, to record the engine condition during incoming, to check for transportation damage, handling damage, and to check for so-called suspected unapproved parts. The borescope inspection is important to figure out what the condition is of the gas path of the engine. This is important information to have in order to substantiate and to control what the planned work scope relates to in terms of the actual condition of the engine. The filter checks are being done to ensure that the oil and fuel system are completely clean, have no further contamination, or do not show any signs of material deterioration on the bearings or accompanying hardware. The purpose of the incoming inspection is to have all that information passed on to our customer support engineer. They're the ones then fine-tuning the final work scope with the customer. The work scope consists out of the basic information of the engine, the reference according to which the customer would like us to work with, the disassembly level, the life-limited part strategy, the material strategy, mandatory and optional modifications, on-wing maintenance requirement items, test and certification requirements, and the preservation and shipping back to the customer.
We have finished our incoming inspection, and I would like to show you what has been found and how we can address the vibration issue.
Oh great, the vibration was a big problem on wing.
Looking at the gas path, no deviations were found. The most probable root cause for the vibration is a high-pressure turbine damper sleeve.
In this case, we have tendency to believe that the damper sleeve is broken. This is one of the most probable root causes for N2 vibration. In order to do this, we have to remove the LPT major module, the module 53, which is the LPT nozzle and HPT shroud module, and the HPT rotor. Once the HPT rotor has been removed, that's when we get access to the broken damper sleeve. Once we have clarified all findings and repaired all necessary parts, that's when we can start reassembly of the engine.
Once exposed and inspected, we can confirm the root cause for vibration and share the inspection results with you.
Thank you. Good day.
Goodbye.
Once the work scoping is complete, the engine is being put onto a transport stand and transported into our engine shop. At the same time, all the necessary preparation steps are being done. Creation of shop order, creation of the necessary work documentation, and the instruction to the mechanics. Once that is completed, that's where the shop visit starts.